औज़ुबिल्लाहिमिनश्शैतानिर्रजीम बिस्मिल्लाहिर्रहमानिर्रहीम रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वाहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली अल्लाहुम्मा अफ़्तह अलैना हिकमतक वंशुर अलैना रहमतक या ज़ल जलाली वल इकराम अल्लाहुम्मा इन्नी अस्अलुका इल्मन नाफ़िअन व अमलन मुतक़ब्बलन व रिज़्क़न तय्यिबा अल्लाहुम्मा आफ़िनी फ़ी बदनी अल्लाहुम्मा आफ़िनी फ़ी समी अल्लाहुम्मा आफ़िनी फ़ी बसरी ला इलाहा इल्ला अंता सुब्हानक इन्नी कुन्तु मिनज़ ज़ालिमीन रब्बि ज़िदनी इल्मा रब्बि ज़िदनी इल्मा रब्बि ज़िदनी इल्मा। अस्सलामु अलैकुम एवरीवन। Okay, now we are going to end this chapter using RLE with images. This is lossless file compression algorithm. We have thoroughly discussed about RLE, lossless file compression algorithm, in our previous class. You can find this video in the description of this video. And if you like this video, please like and subscribe my channel. And now let's go ahead. Yesterday we have discussed about RLE. We have applied RLE algorithm, run length encoding, with this black and white image. How we have applied that is very easy. We consider these white block as considered as one because in binary numbers, one mean binary numbers are digital numbers, 0 or 1. These are known as digital or binary numbers to represent any data or any information in your computer system. So these white blocks consider as 1 on state, and these black color, the black square boxes considered as 0, and we have converted easily into binary numbers like that, 1 1 1 1 1 1 1, and one white color, and then black color. These are black color. Black is represented by 0 0 1 2 3 4 5 6 zeros, and after that we're 1 1 1. And now converting this into binary number, and after converting binary number we have to compress this file with the help of RLE algorithm. So how? So now look here, 9W mean we are having 9 white block in this image, okay, with this grid. Okay, show the letter F in a grid where each square requires 1 byte of storage, and this single square requires 1 byte of information. Take a space of 1 byte on your hard drive or HDD hard disk. A white square has 1 and a black square has a value of 0, and this has a value of 0. So now look here, 9W mean 1 2 3 4 5 6 7 8 and 9, including this 9. You have to write a 9 white. Now black started. Now 1 2 3 4 5 6 black squares, so you just write a 6B, and then so on. Next one, 1 and 2, only 2 white is over here. You just write 2W. 2 represent how many numbers? Okay, how many white colors are there? There are only 2 colors, so that's why W represent white, and 1 black is 1 black. Now again count this one, 1 2 3 4 5 6, and this one 7 white, and then 1 black, and then again 1 2 3 4 5 6 and 7 white again, then 5 black, and so on. That's how you write this in a coded form. Now using W as 1, and B is equal to 0, we get W as 1 where we are having W, and B we have to put these numbers accordingly, these binary values 1 or 0. So finally we will get this value, this number. So now 8 cross 8 grid would need 64 bytes. 8 cross 8 grid mean we are having here 8 rows and 8 columns. These are columns. Vertical collections of these square boxes are known as columns, and horizontal collection of these square boxes are known as rows. And 8 cross 8 mean total 64. 8 cross 8 is equal to 64, means if one square box require 1 byte of information to store this white square, then you have require for all this whole grid, you require 64 bytes to store all this information. So after applying RLE on this black and white image, we are able to compress the storage up to 30 bytes. 64 to 30 bytes. Earlier space required to store this image was 64 byte. After applying RLE algorithm, now it will take only 30 bytes to store the image. Any question till here? Concept clear? So now heading towards the second example. Now let's discuss about the colored image. How to apply RLE algorithm on the colored image. It's very easy. Figure shows 1.3 shows an object in four colors. Each color is made up of R, G and B. Means red, green and blue. These are three primary colors. According to the code to the right, this code, we will consider this code on the right side. So here is our image, colored image. So let's see what we have here. Black color in the first row, 2 blacks, 4 green, and then 1, 2, 3 blacks, 1, 2 and 3 blacks. So let's see. So black color code is over here is to represent the black color we have to write 0, 0, 0. For white we have to write 255, 255 and 255. Why 255? Because it has only how many grades are there? 8 cross 8 and 8 cross 8, isn't it? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 cross 8 grid. So it will require 64 bytes to hold this whole image. So because one square box will take 1 byte of information. To store this square box, we require 1 byte of storage on our hard disk. So when we put this in this formula 2 raised to power 8, this will give you what? 256. 256, just like our binary values. So starting from including 0 till 255, we will get different combination of these colors. So let's start. Okay, now so to produce the following data, this one, how we will produce this data? First we will write 2 here. It means we are having 2 black colors, and now we will write its code. After that we have to write the code of this black color, so 3 zeros. So write 3 zeros over here. Done. Okay, now after that we are having 4 green colors. So write 4. 1, 2, 3, 4. Simply write 4 here. And now check the code. Green color code is over here. This color. This code. After 4 we will write this code. 0 to 55 0. 0 to 55 0 means R is 0. Green is 255. And the blue color is 0. The same way, next one. 1, 2 and 3 black. 3 black, and again we will write the black color code, which is 000. Now after that 6 white. 1, 2, 3, 4, 5 and 6. We just write the number first 6, and now white represent 255, 255, 255. So R is 255, G is 255 and P is 255. So you are able to produce this color, green color, and so on. One black color, 1, and after that put 3 zeros, and so on till line. Till here any confusion? How to write this code to produce the following data with the help of RLE colored image? No question? Okay, now the original image is 8 cross 8, would need 3 byte per square. Because it's now colored image, black and white image require 1 byte of information to store, 1 byte of storage to store each grid. Okay, that is each square. A white square has a value 1 and a black square has a value 1, and 1 byte of storage, where each square requires 1 byte of storage. Okay, now here we have now colored. So for the color would need 3 bytes per square. So we will require 3 bytes to store this one square block. To include all 3 RGB, therefore the uncompressed file for the image is 8 cross 8 mean 64 multiply 3, you will get 192 bytes of information to store your color image or this information in on your hard disk. Any question till here? For black and white image, to store one square we need 1 byte of information, but for the color image, because we are using 3 colors, RGB, 3 primary colors, so we need 3 byte of information to store a single square. To store this single square block, we require 3 byte of information. 3 byte mean 8 multiply 3, 24 bits to store this square block. Okay, so now the RLE code has 92 values, which means that the compressed file will be 92 bytes in the size. So this is called RLE. After applying RLE, we will get what, how many bytes? 92. When you will count this, you will get it's 92. This gives file reduction up to 52%. It will reduce your file size up to 52%. It should be noted that the file reduction in the reality will not be as large as this due to the other data which needs to be stored with compressed file, for example file header. That's it. If you have any question, you can ask now. We have end our data presentation chapter number 1 completely over here. Finally we are able to complete this specific chapter point 1.3, data storage and file compression. If you have a question, you can ask now, because now we are heading towards the second chapter, which is our data transmission, chapter 2.1, types and method of data transmission. If there is no question, I am going to start our third chapter. जी बच्चों, if you like this video, please like and subscribe my channel. Long live Pakistan.